So here we have the 2017 Leaving Cert Ordinary Level question on complex numbers. So this is question 2, and it says the complex number z1 is equal to, so they say z1 is equal to a plus bi. So in a complex number we have two parts. We have the real part and we have the imaginary part. The imaginary part is the part that has the I attached to it. So, and they say where I squared is equal to minus 1. So that's kind of the definition of I. So thereafter putting a point on the diagram, and we have to write down the value of A and the value of B. So basically we have to get the coordinates of this point. So the real axis is the horizontal axis, and this axis here is the imaginary axis. So across on the horizontal axis we run across 3, and on the vertical axis, or the imaginary axis, we went down 1. So our point, so for our real part is going to be 3, and our imaginary part is going to be minus 1. So our point will be 3 minus 1i, or 3 minus I. But they didn't ask for a point, they asked for just the values of A and the value of B. So they gave it in the form A plus BI. And if we compare ours to this, well, A is equal to 3 and B is equal to minus 1. So that's the value of A and B. And then the next one, it says Z2 is equal to minus 1 plus 2i. So we have to plot this. So we went minus 1 and then plus 2i. So this is our 2i and then minus 1 on the real axis. So this here would be Z2. So my diagram isn't 100% accurate because I don't have graph paper. So, and then the next part, so I'll just go on to a new page. And we're told that another complex number, Z3, is equal to Z1. And we're already after getting Z1 from the last part, which we got was 3 minus I. So I'll just write out what we know. So Z1 is 3 minus I, Z2 is minus 1 plus 2I, and Z3 is equal to Z1 over Z2. So Z3 is going to be equal to 3 minus I over minus 1 plus 2I. Now, they didn't ask to express it in this form. They asked to express it as a real number and then an imaginary number. So they wanted it in this format. So when I have a complex number divided by another complex number, this is an example of division with complex numbers. So there's kind of a few steps. So the aim of this, what I want to do eventually, is I don't want to have any complex parts on the bottom of my fraction. And one way to do that is to multiply the complex part on the bottom by its conjugate. But if I'm multiplying the bottom by the conjugate, I'll also have to multiply the top by the conjugate, so the fraction stays balanced. So if I had minus 1 plus 2i, the conjugate is literally just, it's pretty much the exact same, except we change the sign in front of the I. So the conjugate of this will be minus 1 minus 2i. So the steps for when we have division with complex numbers is we multiply, and I would recommend learning off the steps, having them ready in your head. So top and bottom of the fraction by the conjugate. So remember, the conjugate is just when we change the sign of the imaginary part, conjugate of the bottom, because we want to get rid of the complex part on the bottom. So our equation is 3 minus I minus 1 plus 2i. So this is what we're given. So we multiply top and bottom by the conjugate. So minus 1 minus 2i minus 1 minus 2i. So then we're going to have 3 minus I by minus 1 minus 2i. I'll just move that. And then we have minus 1 plus 2i, and then minus 1 minus 2i. So I'm just going to bring it down to say here. So what I might do is when I have two brackets together and I'm multiplying them, I would split my first bracket, so 3 by my second bracket, and then minus I by my second bracket. So 3 by minus 1 minus 2I, and then minus I by minus 1 minus 2I. And then I'll do the exact same on the bottom, so minus 1 by my second bracket, so minus 1 by minus 1 minus 2I, and then plus 2I by minus 1 minus 2I. So then I have 3 by minus I, so that gives me minus 3. Sorry, 3 by 1, which gives me 3 by minus 1, which gives me minus 3. 3 by minus 2I, so that gives me minus 6I. So minus I by minus 1 plus I, and minus I by minus 2I, so that'll be plus 2I squared. So then we have 1, minus 1 by minus 1 gives us 1, so minus 1 by 2I gives us plus 2I, so here I'll get minus 2I, and then we'll get minus 4I squared. So we see we have a plus 2I and a minus 2I, so they'll just go to 0. And then I'm just going to group together the terms that are the same, so I'll keep my minus 3 where it is, so I have minus 6I plus I, so that'll be minus 5I. And I was told in my question that I squared is equal to minus 1. So instead of putting 2I squared, I'm going to put 2 by minus 1. And if I multiply 2 by minus 1, I'll get minus 2. And then on my bottom, I have 1 minus 4. And instead of I squared, I'm going to sub in minus 1. So then I have minus 3 and minus 2, so that'll be minus 5, minus 5I, and then I have 1, so then that's 4 by minus 1 gives me minus 4, and then a minus by a minus gives a plus, so 1 plus 4 is 5. So now I have to divide each of them by what's on the bottom, so minus 5 over 5I, so that's what I just move the page up, so this is what I get, and then I just have to divide both of them by 5, so I get minus 1 minus I, or minus 1I. So that is in the form x plus yi, and that is my answer for Z3.